Hi, this is John Linneball, and this is How to Study for the SAT and ACT Math section. 1 is the loneliest number. We're going to review the properties of 1 for this video, and if you like this video, please give me a thumbs up at the end, and please subscribe to this channel. Thanks a lot, and I'm John Linneball from John Linneball Tutoring, and here's my contact information if you need to get in touch with me. Thanks. Alright, so let's get started.
1 is the loneliest number that you'll ever do.
Alright, so why is 1 the loneliest number that you'll ever do? Well, why should you care about 1? Well, come on, haven't you heard look out for number 1? 1 is incredibly important in mathematics. It helps us solve equations and more. Not bad for just one number. 1 is special. It has a unique identity. Anything times 1 is that same thing. Anything divided by itself as 1 as is anything to the 0 power. So 2 divided by 2 is 1, smiley face divided by smiley face is 1, smiley face to the 0 power is 1. The only thing that is not 1 when you take it to the 0 power is 0, because then it becomes meaningless. You know, is it equal to 0 or is it equal to 1? So not literally anything. 0 is the one exception to that. 0 to the 0 is a meaningless expression. The properties of 1 for any non-zero number n times 1 over n, so n times its reciprocal, is equal to 1. So as we see here, the product of any number n and its reciprocal, 1 over n, is always 1. For example, 3 times 1/3 is equal to 1. Sorry for writing it twice, but I did, so sue me. 1 is smaller than all other positive integers and larger than 0 and every negative integer. Any non-zero number to the 0th power is 1. Why is that? Well, since a to the x times a to the y is equal to a to the x plus y, a to the x times a to the 0 is equal to a to the x plus 0, which is equal to a to the x, which is the same as a to the x times 1. Therefore, a to the 0 is equal to 1. So there you have it. More properties of 1. Okay, again, any non-zero number multiplied by its reciprocal is a over b times b over a is equal to 1. You know, it's 1. So 1/2 times 2, 2 over 1, which is just 2, is equal to 1. 2/3 times 3/2 equals 1. So that's good for solving algebraic equations. The probability of anything has to be between 0 and 1. Sometimes it's expressed as 0% and 100% inclusive. If the probability of something is 0, that means it's impossible, and if the probability is 1, that means it's a certainty. There's no way it cannot happen. It has to happen. All right. So 1 is good to plug into equations and geometry problems. 1 doesn't count as a prime number. It's the only integer with only one divisor, so no wonder it's the loneliest thing you can ever do. The loneliest number you can ever do, I mean. All right, anything multiplied by 1 is that thing. This makes sense if you again recall 1 is just a single thing. 1 times an apple is just that one apple. Multiplication is just repeated addition, so 2 times 1 equals 2. It's just a single 2, so 2 times 1 equals 2. Since 1 divided by 1 equals 1 and 1 times 1 equals 1, 1 is its own reciprocal. A reciprocal of a number is simply 1 divided by that number, and the product of any number and its reciprocal is 1. 1 is a factor/divisor of every number, since anything times 1 is that thing. Anything divided by itself is 1, even units or other non-numbers. For example, smiley face divided by smiley face is 1, miles divided by miles is equal to 1. So that's useful in dimensional analysis, as you might find in your chemistry or physics problems. Dimensional analysis uses the properties of 1. If we line up the units correctly, using the conversion factors correctly, all the units we don't want in the answer should cancel out as equal to 1. Conversion factors are always equal to 1. For example, since 1 kilometer equals 1,000 meters, 1 kilometer over 1,000 meters equals 1, and so 1,000 meters, and so is 1,000 meters divided by 1 kilometer. Putting that conversion factor into a problem is multiplying by 1 and doesn't change the value of your result. So here we have a dimensional analysis problem. A car is driving 65 miles per hour on a highway. How many feet per second is the car driving? There are 5,280 feet in a mile. 65 miles per hour times 1 hour over 60 minutes. See, 1 hour is 60 minutes, so that's equal to 1, times 1 minute over 60 seconds. Same thing, 1 minute is 60 seconds times 5,280 feet per mile, in 1 mile. Okay, so we see the mile cancels out the mile. The hour cancels out the hour. There's a minute on the bottom and a minute on the top, so they cancel out. So all we have left is feet and second. So we end up with 65 times 5,280 feet times 60 times 60 seconds. So we can factor this out. Factoring is a great way to do things if if you're good with your multiplication tables, so you don't have to get out your calculator. So I know 65 is 5 times 13. And then I know that 3 times 1760 is 5280 because I know how many yards are in a mile. So then we can go, all right, so that's 5 times 13 times 3 times 1760 over 60 times 60. Well, all right. I know that 1760 is 4 times 440. So we have 5 times 13 times 3 times 4 times 440 times 4 times 15 or divided by 4 times 15 times 4 times 15. All right. One thing I know is that 440, as you can probably guess, is 4 times 110. So that cancels out a 4 here and a 4 here. And then this 4 and this 4 cancel it out. And we have a 5 and a 3. So that is a 15. So that cancels this out. So we end up with 13 times 110 over 15, which is going to be equal to 13 times 5 times 22 over 3 times 5. These 5's cancel out, so I end up with 13 times 22 divided by 3, which is roughly 95. Well, it is 95 and a third, or 95.33333333. You could put a little bar over the 3 if you wanted for your answer. So it's 95 and a third feet per second. One is useful to plug into equations. If no values are provided for variables in a problem, but ratios between the variables are, try making the smallest variable equal to 1. Example, assume that a, b, c, and d are all positive integers. If a is equal to 2b, b is equal to 2.5c, and c is equal to 5d, then we can see that b must be smaller than a because a is equal to 2b, b is equal to 2.5c, and c is equal to 5d. And since they're all positive integers, then it has to be that d is the smallest and a is the largest. So what is a in terms of d? Well, okay, first thing we can say is, all right, if we set d equal to 1, as we suggest here, then it's easy to use. So you just say, all right, c must be 5 because it's just 5 times 1. And then b would be 12.5 because that's 2.5 times 5. And then 12.5 times 2 is just 25. So that means since a is equal to 2b and b is equal to 12.5, a is equal to 25. So since a is equal to 25 and d is equal to 1, a has to be equal to 25 times 1, which is 25d. Pretty easy, right? 1 is also useful for testing math statements, especially on SAT problems where they'll give you something like this, or maybe even on the ACT. You might run across a problem like this. True or false, for all integers, x squared is greater than x. X cubed is greater than x, where x is greater than 0. Or 3x squared minus x is greater than 0. Okay, so answer A might be only statement 1 is true. Well, you'd say, all right, well, 2 squared is 4. That's bigger than 2. That works. Let's see, 2 cubed is 8, which is greater than 2, and they're saying where x is greater than 0, so it's not like you're cubing negative 2 where you get negative a. So yeah, that works. Then 2 squared is 4 minus 2. Well, that's 2. That's greater than 0. That works, but what if you plug in 1? 1 squared is 1, which is equal to 1, so number 1 isn't true. 1 cubed is also greater than 1, or sorry, it's equal to 1 rather, so that's not true. And then 1 squared minus 1 is equal to 0, so none of those are true. So it's D, neither 1, 2, nor 3. And here we have A is false for the reason I just told you. 1 squared is equal to 1. B is false, well, because 1 cubed is equal to 1. And C is false since 1 squared minus 1 equals 0. 0 is also good for this. If you plug it into these equations, you would get things like 0 squared, okay, is not greater than 0. 0 cubed is not greater than 0. 0 squared minus 0 is also not greater than 0. So you want to plug it into equations that look like they're true for all integers or all rational or real numbers. Fractions and negative numbers also work well for testing these kinds of things. All right, so the same applies to geometric problems. If a rectangular solid is increased in length by 50%, in height by 75%, and in width by 25%, what is the total percent increase in the volume of the solid? Solution. Assume the solid is a cube with edge 1. Then the original is just 1 unit times 1 unit times 1 unit, which is equal to 1 cubic unit. So how do we finish? It's simple. Since the length is increased by 50%, the new length is 1.5 units. Since the height is increased by 75%, the new height is 1.75 units. And since the width is increased by 25%, the new width is 1.25 units. So the new rectangular solid, it's no longer a cube since the sides aren't all the same length anymore. It's going to be 1.75 times 1.5 times 1.25 cubic units, which is 3.28125 cubic units. So the percent increase is 3.28125 minus 1 over 1 times 100%, which is going to be 2.28525 times 100%, which is roughly 228%. You won't have room to put a fourth or fifth digit on a grid in. If it's multiple choice, just pick the closest one. So if you want to see me actually do that on the calculator, I can do that right here. So it's just going to be 1.75 times 1.5, which is 2.625 times 1.25, which is 3.28125 minus 1. Isn't it good that we had a cube with volume 1? And then we have to divide that by the original value. Hey, that's 1, so we don't even really have to divide, but we can. So it's 2.28 times 100%, just voila, 228. So that's probably going to be all the room you have to write, or it'll say approximately 228 or 228.125, whatever. Anyway, you'll see it. So notice that it was really easy to subtract 1 and to divide by 1 in the percent change formula. So isn't it good that we used 1? All right, I hope this helped. If you have any comments or questions, please leave a comment below or contact me at the phone or email at the beginning of this video. If you like this and you want to help me make more videos, like this video and subscribe to my channel. I do in-person and online tutoring for the SAT, ACT, and more. Again, thanks for watching this. Okay, have a good day.